So in this video I'm just continuing with some GCSE density questions from the last video. Question 5. Archimedes once may have had to determine if the king's new crown were made of pure gold using the pair of scales set up below. Explain how he could find out. So the mass of the pure gold would be equal to the mass of the crown. So the crown is pure gold if it displaces the same volume of water as the pure gold mass, right? So if it's made out of pure gold, then it would have the same effect of displacement of the water. Or he could lower both onto a balance into water. If it remains horizontal, then the crown would be gold. Question 6. A piece of metal has a volume of 40 centimetre cubed and its mass is 108 grams. Calculate the density of the metal. Density is mass divided by volume. 108 grams divided by 40 centimetre cubed gives 2.7 grams per centimetre cubed. So what type of metal would that be? Well, look at the table and compare it, and it's the same as the density of aluminium, 2.7 grams per centimetre cubed. Note that expressions of density in kilograms per metre cubed are 1,000 times, result in a value of 1,000 times greater than an expression in grams per centimetre cubed. A brass ball has a diameter of 10.0 millimeters. A. Calculate its mass. B. Calculate the diameter of a ball of gold at the same mass. So first of all, we need to know what its volume is. So we calculate that using the diameter given. So the formula for volume of a sphere is 4/3 pi r cubed. This is then 4/3 pi is a constant multiplied by r cubed. Well, r is going to be 1/2, okay, because the diameter is twice the radius, so the radius is half of the diameter. So this should be half of the diameter cubed, should say in there. So there should be a little d in there. Apologies for that. So what we're doing is we're doing 4/3 pi multiplied by a half of this diameter, so that's going to be 5 millimeters. So it's 5 in there, 5 cubed, and that gives 0.523. If we have to convert this millimeters into meters, so in order to do that, we have to divide by 1,000. So we'll have 5 millimeters divided by 1,000 is 0.005. So that's what's going to be in here. So it's going to be 4/3 pi times 0.005 all cubed gives 0.523 meter cubed. Then find the mass. The mass is the density times the volume, which is 8.5 times 0.523 equals 4.5 grams. A piece of metal is 2 times 3 times 6 centimeters and its mass is 270 grams. A. Which metal is it most likely to be? Well, what's its density? Mass divided by volume, use that formula. Substitute in 270 grams divided by the volume, which is 2 times 3 times 6. So this gives you 7.5 grams per centimeter cubed. Try and do that on your calculator. And then we compare it with the table up here, and this value, even though it's not exactly the same as the 8.5, that's what it's closest to, so we're going to go with that it's most likely to be brass out of these 4 metals. A part 2, calculate the weight of the piece of metal. So the weight is mg, so that's equal to 0.2 times 70 times 9.81. Sorry, the mass is 0.270, that decimal point shouldn't be there, 0.270, so that's this weight in kilograms, this mass in kilograms, multiplied by 9.81, which is equal to 2.65 newtons. B. Draw a diagram of the metal submerged in salt water, add the weight and upthrust forces to the diagram. So we've got the weight going down and the upthrust going up. There should just be one arrow there. Part C, calculate the upthrust on the metal. So the upthrust is equal to the weight of the displaced fluid. That's Archimedes' principle. So the mass is density times volume. So that's 1.2 times 2 times 3 times 6 gives you 43.2 grams. The weight then is mg. So the mass needs to be in kilograms. So that's 0.0432 times 9.81 gives 0.42 newtons. Part D, calculate its apparent weight when it's completely immersed in salt water of density 1.2 grams per centimetre cubed. The apparent weight is 2.65 minus 0.42 gives 2.23 newtons. 9. A person tries to sell you a piece of metal claiming that it's gold. It looks like gold, but you have doubts. You find that the real weight and the piece of metal is 2.5 newtons, and that its apparent weight when completely underwater is 2 newtons. So the buoyancy of the water is holding it up a little bit. So the apparent weight is less. Should you buy the piece of metal? Explain. So first of all, we'll try and work out what the weight of the fluid is that's being displaced. So the weight of the fluid displaced, well, that's going to be equal to the difference between the actual weight and the apparent weight. So the actual weight is 2.5 and the apparent weight is 2. So the difference between that is 0.5 newtons. So that's the difference, that's the upthrust or the buoyancy caused by the displacement of the water. And that's equal to the weight of the fluid displaced. So it's 0.5 newtons. So that's really key principle. The mass of the water then is the weight divided by G. So that's 0.5 divided by 9.81 gives 0.051 kg. Therefore, the volume is the mass divided by the density, which is 51 divided by 1 gives you 51 centimetre cubed. Then the density is the mass divided by the volume. So that's 2.5. That's this is now the density of the metal that we're trying to work out, the object. Mass divided by the volume. The mass of the object is 2.5 divided by 9.81 because this is the weight, right? So you've got to divide it through by 9.81 to get the mass. So this in brackets is now the mass. Multiplied by 1,000 divided by 51, because if you divide something here, see this is the top bit, this is the mass, and the volume would be 51 divided by 1,000, but instead of dividing through by 51 divided by 1,000, we can just use simple algebra or arithmetic, and that is equal to multiplying by 1,000 divided by 51 rather than dividing by 51 over 1,000. That's the same thing. So the density is 4.99 grams, approximately 5.0, well, two significant figures, that's 5.0 grams per centimetre cubed. So 5.0 grams per centimetre cubed, if we go back up here, is much less dense than gold. So it's not gold. It's not pure gold, it's nowhere near pure gold, so don't buy. The density of the metal is 5.0 grams per centimetre cubed. Question 11. Which items of apparatus are required to determine the density of a liquid? Well, you need a balance and a measuring cylinder. So you would fill the measuring cylinder with the liquid. Before you did that, you would measure first of all, you'd measure the mass of the cylinder, then you would put the liquid in the measuring cylinder, you would measure the volume of the liquid, and you would measure then the mass of the cylinder plus the liquid. You could then calculate the mass of the liquid by subtracting the mass of the cylinder plus liquid minus the mass of the cylinder. Then you could work out the density by doing mass of the liquid divided by its volume. Question 12. A cube of side 2.0 centimeters is placed on a top balance. So its volume, if it's cubed, it's a cube, so therefore it's 2 by 2 by 2 centimeters, so its volume is 8 centimeter cubed. And then its density is mass divided by the volume, so it's 7.2 grams divided by 8 centimeter cubes gives 0.9 grams per centimeter cubed. So it's A. Question 13. Two identical measuring cylinders containing different liquids are placed on a simple balance. They balance as shown. Here we can see that the cylinders are equidistant from the pivot, so they're the same distance from the pivot. We know what the density, well, this would be the formula to work out what the density of liquid X would be. It would be its mass divided by its volume. We don't know its mass at the moment, but we know its volume. And likewise, the density of Y would be its mass divided by 100. How does the density of X compare with the density of Y? So we can see that in order for the balance to balance, in order for this beam to balance, these masses must be equal because the perpendicular distances are equal, and therefore the moments are equal. If the moments are equal, the perpendicular distance is equal, therefore the masses are equal. So this is why this little m is the same as little m here. So this density here is m divided by 200, and this density is m divided by 100, so this density is smaller, it's half the size. X is half the size of Y. Its some value divided by 200 results in a smaller value than that value divided by 100. So A is your answer. Again, shown here, density of X, we rearrange this, m over 200 equals a half times the density of Y. 13b, if the experiment was done on the moon instead of on the Earth, how would this change the answer? Explain. The mass and the volume would be unchanged, so the density would be the same. Density of X is half the density of Y. The weight of X and Y would both decrease.